Good afternoon, ladies and gentlemen, and welcome to BCCK webinar, this time on a very interesting topic related to synthetic data. And it's my pleasure to invite Chris and Noman to speak today, but particularly Chris to lead on this topic. So what are we going to discuss? Well, issues surrounding, what is, huge amounts of what they call training data, which is needed for AI systems, and also introduce the platform which here Mindtech is providing to address the issues which allow data scientists to create and curate photorealistic synthetic data in unlimited volumes. So there'll be an introduction, sort of a little bit about the company, but also what they do in order to what they teach machines to see, training data requirements, synthetic data benefits. How does the help in overcoming issues around real data, and then also the platform itself. So there will be Chris Longstaff, who's VP of Product Management at Mindtech Global, which is kindly here to present. It's a little bit early in the UK, so thanks very much, Chris, for doing that. And also Noman, who's VP of Sales, who will help particularly with the Q&A. So for those of you attending, there is a chat function. So if you're interested in, just asking a question, feel free to write it in the chat box. In the event that you would like to, have any question asked, then just type it in there, and we will actually provide you with a bit of a suggested question in a second, and they'll be answered at the end. So please do. And then also we will follow up with everyone on the call, and those not able to make it onto the call, to provide a link for the contents, and also to see if there's any opportunity for you, the companies here, to maybe work with the Mindtech solution as well. So, but without further ado, I'd like to just pass that over to Chris. And do you want to share the screen, Chris?
Okay, good morning, everybody, and or good afternoon there. Thank you for attending the session today. So, as Sean's given an introduction, I don't really need to go through this anymore, but Mindtech was founded in 2017. We really started this project on the synthetic data late 2018, early 2019, multiple office locations. I've been involved since nearly the outset at Mindtech, and throughout my career have focused on a lot of these visual technologies. So I'm going to try and lay some foundations here today. Appreciate that some people on the call may understand this very well. There may be some others for who it's new. So apologies for those who perhaps know the topic very well. So today, everywhere we go, we see AI systems, and particularly visual AI systems, whether it's on your smartphone, on the cameras, in your car, we're seeing AI. And there's three key elements to any AI system. There's the hardware. And so the hardware is going to be where you're doing the training. It's going to be where you are doing the inferencing in deployment. A level up from that, you're going to have the particular network and algorithm that you're running. And that is going to be basically something along the lines of a ResNet network, an object detection network, perhaps a segmentation network. And really, obviously, what we're talking about today is the key of all three pillars here. It's the data. So this is the data that you're going to use to teach the network, to teach the AI system, as well as the data, obviously, that's going to be used during deployment that produces the actual results. But really, data is absolutely key to any AI system. And just as a brief overview of the very, very basic concepts here of training the network. So how most networks work today, we use annotated data. That means that every single bit of data that we use has some annotation to explain to the system what it is. So in the example here, we are feeding the network some images and we're explaining what a banana looks like, what a car looks like, different views of bananas, what a tiger is. So we go through an iterative process there of training, and we run the training, we look at the error, we change the weights that we're doing, we predict it, measure the error again. And this is an iterative cycle, the training cycle, until we end up with a trained network. The next stage is then to test that. So in the example I've given here, again, we've tested it with a banana, and that has successfully identified it's a banana. The next item comes in, which is a tricycle. We've successfully identified that it's not a banana. The third example, we've done a zucchini or a courgette, and it says it's a banana. Now, in this example, it's very easy to see why the example of the zucchini might be confused with a banana. But this is obviously showing a weakness either in our network framework or in the data sets that we've chosen. So clearly, there are, at this point here, in a real system, we may want to go back around the loop, back to the training side, and examine both our network and our training data set to try to improve the accuracy of our predictions. So, what is it that the data scientists actually want? They basically want easy access to appropriate data. And what that means is the right training data for the task in hand. And one of the other key things about AI systems is that there is a vast variety of different objectives. And so getting the right data for that accuracy is important. So there's a difference, for example, between detecting that a person is present and detecting who that person is. There's a difference between detecting that someone has their hands up and that someone has their hands in fists. But in some instances, all you may need to know is that the hands are in the air. And so what the data scientists want is the ability to generate that data very, very quickly and gather it. And the way that we approach that data gathering is with synthetic data. And so our target is always to accurately model the real world, both visually and statistically. We want to automate that process. The process needs to be automated to make it as easy as possible for engineers. And we want to automate that feedback loop, which we just discussed, from where we've identified a zucchini as a banana. We want to identify that feedback loop to automate that data. And you can see on the right a couple of quotes here. So, it's a real problem for the data scientists. The top one there, if you work in AI, your time is spent collecting data, cleaning data, labeling data, splitting data, training with data, evaluating data, all from model to say it's a cat. So what that's telling us, we see that we talk to people who say that up to 80 to 90% of a data scientist's time can be spent on this data side of things. The other article there as well, pointing out some of the issues with data. They're collecting data, but it's biased. It doesn't have privacy and doesn't have consent. And we'll come to cover that in more detail. So the considerations here for the data gathering, we really do need to think from the outset, what is the problem that we're trying to solve? What's the accuracy that we need? If we're trying to count the number of people into a shopping center, so we're trying to count that, perhaps we decide that an error margin of maybe even 5% is okay. And we're okay that if we get 95% to 105% of people counted, this is okay. On the other hand, if we're trying to do a system which is identifying where incorrect safety equipment is being used in a hospital operating theatre, we want a much, much higher standard of accuracy there. This could cause critical issues, and so we might want 99.9% accuracy in terms of that detection, or even higher. So we have to very much understand the problem in order to understand the data. Now, one of the issues is that people go, where do I get the data from? And they'll often start with what's called a pre-trained network. So what they actually do is they go and they will find a pre-trained data set trained on something like ImageNet or Coco and use that. The issue there is you can't use that for commercial implementations. You also don't really understand what data's in there if you haven't sourced it yourself. So there's significant issues around using existing data sets and pre-trained networks. On the right-hand side here, we're explaining, we do need a lot of data. We need that training data we talked about. We need extra validation data for model optimization. And these first two boxes here can use significant quantities of synthetic data. The test data down at the bottom here, which is testing for the model performance, is obviously what is going to be real world data. That's going to be actual data that you expect to get in the real world so that you can test the system. And then obviously it's a continuous thing. You continuously need to check your model. And as we'll talk about in a minute, issues like data drift come into play, where actually over time, we need to update this model and go back to our data sets. So that question we've just talked about, how many images do we need? It's very, very difficult. The real world is not necessarily logical. The top two images here, one is representing someone who is stealing an item from a store. The other one represents someone who is just removing a phone from their pocket. To you and I, the context will help us understand that one is illegal and one is not. To a computer, we need to teach them that difference in context. As I mentioned, there's a data drift. So over time, the requirement for data changes. And what we see here is, this is an example, a photo of me last year. And then, of course, we needed face masks. And, I deliberately put on a face mask here, which is not just plain and white. It's a difficult, item to understand. But all of a sudden, 2 years ago, nobody cared about finding data with face masks. 12 months ago, everybody wanted data with face masks. Something that happens, can happen very, very quickly. Other examples might be a new car coming out, a new packaging for supermarket items. So data changes rapidly over time, and we have to make sure that we are updating our data sets with appropriate data. And again, on that story of appropriateness, if we're looking at smart cities or things like that, we can have lots of images of this road on the left-hand side here, and people might think, I've got a lot of road images, but if they're like this on the left-hand side, that doesn't help my smart city, which has a very complex roundabout like this one here on the right-hand side. So for smart city, making sure that we've got the correct images is vital. And just to give an idea, the top accuracy here in object detection, this has used 303 million images to train it. That gives an idea of the kind of scales of data that we're talking about here. So we're not talking about 1,000 images, 100,000 images. We're talking millions of images can be required to get the best results. Looking at this as well, it's important that we've got the right data and the right amount of data. So this example here, we're trying to identify perhaps occupancy of park benches, how well are people sitting on the park benches. But what this problem is actually about is, actually, we just want to identify the overall utilization of a park. So identify people sitting down in a park. If we've only used these images on the left here, which are sitting on park benches, our network will very quickly understand these are people sitting on park benches, and it will be very good at that. But all of these examples on the right-hand side here, we won't actually understand, and the system will not be able to predict all of there. And so getting the right data and the right amount of data is very important so that we correctly fit our model. We don't want to have overfitting. We don't want to have underfitting. We want the correct level of diversity. The traditional manner to collect this data is, obviously you can go and try and source the data sets that I talked about on the internet and things like ImageNet and Coco. These, as I've mentioned, very, very difficult to use commercially and an unknown quantity. So you may decide to go and gather your own data. So this involves setting up a filming studio, setting up a filming location, hiring actors, finding the appropriate locations and recording that. And this is going to cost thousands and thousands of dollars a day. It's going to be difficult to get the corner cases recorded. And even when I've collected all of that data, I then need to go and get that annotated. And if I'm doing some even moderate annotations, that's going to cost significant amounts. You know, we see typically here $3 upwards an image. So as I've just mentioned, we might be looking at 100,000 images for a trial data set. And that's going to be a significant cost to label and also significant time. So, you know, 100,000 frames is going to take, you know, roughly 16 weeks to get labeled. That means your competitors can be ahead of you because you've taken all of the time to get the data to start to prove your system. We're also going to need to augment those images. There's lots and lots of corner cases with things like different cameras, interference, lens distortions that will cause issues for our training data. We need to make sure that our system can understand those likely impairments with the training data set. And to try to capture those in the real world is very hard. You're going to have limited opportunities to capture those specific instances. And we need to be able to augment our data set with these typical issues. Again, this will come down to case by case. Only the customer will know what are the important augmentations for their specific use case. So, you know, someone who is working in an old building might be suffering from that poor electrical installation. Someone who's working in extreme climates might well suffer from the condensation on lenses. It's going to depend very much on your specific application. And that, again, is something where the real world data is problematic. It tends to be very generalized and not specific to a customer's application and requirements. So I just tried to summarize here in a single slide a number of the issues of real world data. And, you know, we've talked through some of them already. I'm going to focus on a couple more here. So we've talked about the fact that we do need very large data sets and dealing with the data drift. The privacy and the GDPR, I mentioned having to hire actors. This is a really hot topic. And, you know, today we're seeing people are using content for training networks, which they don't have the rights to. And increasingly in legislation today, in the law, there are a number of things where you can no longer go out and use whichever data you happen to find on the internet. You have to be using data that you can prove the provenance of, you can prove where it came from, that it is privacy compliant. Because if you deploy a product and you've used my image without permission, this could cost you millions of dollars when you have to recall the product and reissue the software for it because you've used illegal images in your training. This really is a ticking time bomb, this one. Getting hold of all of the corner case data is difficult. You know, in the real world, how often will you be able to actually film someone who is doing pickpocketing? So you would need to set this up with actors, and then you're going to have very limited amounts of data available. The annotations that I've mentioned, so it's vital that all of the data that you have is accurately annotated, and doing annotations by hand is very difficult, particularly as we look at some of the advanced ones we'll come on to. Having the appropriate environmental conditions, perhaps you've gathered all of your data in San Francisco or in London or in Tokyo or in Seoul. And the data that you gather in Seoul would be very, very different from that data gathered in London, Tokyo, San Francisco. Therefore, the ability to reuse data is vital if you want to deploy products worldwide. We see here again the example of a typical overhead camera here. Now, this kind of imagery, if we haven't got that imagery used for our data set, our AI system is not going to understand how the data coming into it is going to look. We need to match that. Appropriate camera angles is vital. So understanding for your individual installation where the cameras are likely to be and having data appropriate to that is critical. And having generalized data often means that the camera angles and the points of view will be inappropriate. Being able to prove the data provenance, again, this is something coming with legislation, coming with legality. And what we see here is that increasingly, you're going to have to prove, how was your AI system trained? Is it fair? Is it avoiding this bias and diversity? And if you can't show that you have taken the right approach to that data and got the data provenance and can prove where it has come from, then there will be liability for your system, which could be very, very costly in terms of both product recalls and in terms of legal proceedings. So what's the answer to this? So one of the answers is the use of synthetic data. This is something where we create a virtual world, and the top left there, you see our large office scene, and we create this virtual world. Into that virtual world, as you see on the right-hand side there, for a smart city scene, we've placed actors in the scene. We have the police cars there, we have the vehicles there, and we create the smart city scene. We get the pixel perfect annotations from synthetic data and comprehensive database. So I'm going to talk through now, but there is a huge amount of benefits to using synthetic data. So one of the first things to look at is a comparison of how does the real world data compare with the synthetic data. I'm not going to read off this whole table, you'll have it later on, but I'm going to highlight a couple of things. So first of all, one of the criticisms that people often highlight at synthetic data is that they worry about whether it is going to be accurate to the real world. And in terms of this, you'll find that, as I've just mentioned, things like the distortion of a camera lens, actually only synthetic data will get that accurate. Real world data may well not get that accurate. So actually, synthetic data can be in some ways more accurate than real world data for the intended inference system. Another one just to sort of highlight down here is this, the model interaction. So one of the things that Mindtech in particular focus on is that human to human interaction. And what we do here is that we have the ability to look at the way that humans are interacting with both each other and the objects around them. And because we can simulate that, if we want to simulate a fight, we want to simulate someone falling out of bed, we want to simulate someone with a trip hazard in a store, all of these kind of elements can be simulated very safely, very accurately by the synthetic data generator that Mindtech have. Doing this in the real world is very expensive and potentially dangerous. In terms of where we see the proportion of real and synthetic data, typically we would expect that around 90% of data can be synthetic. It could be 90 to 95% synthetic data with only a very small proportion of real data. And in fact, for a lot of training, we will actually use 100% synthetic data. And the example that, down at the bottom right here actually shows that using, a combination of real and synthetic data actually improves the accuracy over using real data only. So if you think about this example here, the cost and the time of gathering all of the real images is is huge. We've reduced the need for the real images and improved the accuracy. And again, the same picture is seen at the top here, whereby the most accurate that we can get is by using a combination of real and synthetic images. And we've vastly reduced the number of real images that needed to be labeled. So we are faster to market at a lower cost with a more accurate solution. So how do we do this? We use the Mindtech Chameleon AI training data platform. There's a large number of elements to this. I just want to talk briefly through the typical flow. So at the bottom left here, we bring in 3D artwork models. These are industry standard artwork models, some of which we create in-house, but we can also use off-the-shelf models that are commonly available from studios, from sites around the world which have 3D models on. We convert these from the artwork into smart assets. And what we mean by this is we prepare them for the simulator. So we have to add behaviors to these assets. We have to tag and label them. We have to create the things which will enable us to have perfect annotations of them. So we have a toolkit which helps us and helps our customers be able to import that 3D artwork. We then go through with our assets, and we use the scenario builder to, with our scene, enter assets into that scene, build up, if you like, it's our film studio. So the scenario builder is where we put together our actors, our vehicles, our items into a scene and tell them what they're going to do. This is our film studio. The simulator, this is effectively making our movie. This is making our film. So here we get the images out, we get the annotations out. But what's key here is that this is automated so that we don't have to tell an actor everything that they're going to do. We give them instructions. We tell them to go around the supermarket and collect items off the shelves. We tell them to drive a car around the road to this place. The cars will stop at traffic lights. The pedestrians will stop and pick up a shopping trolley. This is all automated so that it makes it fast and easy for the person trying to create the data set. And then we go through the curation manager. And this is where we're going to look at what content that we've created. We're going to augment that content. So we talked about the augmentations there. And then we're going to use the curation engine to discover the data that we've created, understanding then, have we created the right data? Do we have the right balance of data? And because, as I mentioned at the outset, data scientists, machine learning engineers, companies, they want to spend their time on the bit that they add value to. And the bit where they're really innovating, this is where the customer makes the difference, is this network. This is where the customer really, really differentiates. They do differentiate on the data that they create as well. But at the end of the day, what they need is they want to have a scene pack from us. That means we can create and deliver to the customer the scene they want, whether that be an underground parking lot, a cinema, a smart city scene. We create that. We create the assets to go in it, the vehicles, diverse pedestrians, and so on. We can create scenarios which are telling people, how's the incident occurred? Let's set up the paths and of people. Let's set up the distribution of assets within a scene. And the application pack is really about putting that all together, having the scene, the scenario, and some assets to put all of that together. So just a little bit more detail on each of the elements now. So we have the asset manager. The asset manager is, as I mentioned, where we take the artwork, we tag it, we label it consistently. And it's really important that this consistent labeling and tagging is occurring, because what this enables is us to find the items later on when we're looking at our data set. So if we want to find, where is a bench in my data set? Where is the woman wearing red in our data set? We need to have that consistent labeling and tagging. And this is a very simple, straightforward flow, easy for people to use. And you'll see that throughout the platform, we use JSON file formats. So that means that the data scientists can read them. The data scientists can write Python scripts to process them. So this is all open for our customers so that we enable them to really be able to search and process their data as they need to. The scenario builder is where we're going to set up, and as I say, it builds the story. This is our film set. So we have a full 3D UI for placing items in. We can do complex circuit and path planning in there. We can then auto-populate things, so we can create things like this supermarket shelf, auto-populated, placing the items in at random. We have the simulator itself. As I mentioned, this is what's going to drive this is effectively the filming. And this is fully scriptable as well. So whilst we have the nice UI, the machine learning engineers also can run this from the command line. So you can very quickly build up a series of scripts to build very, very large data sets to meet your requirements. There's a lot of power within the simulator as well. As I say, we have automated behaviors. We have things like attractors and generators. So the attractors can change the behavior of people within a scene. Things like the automated behaviors here we see. So picking up difficult to pick up objects. This is all automatic. There's no need to tell the actor how to pick it up. The actor understands how to pick up complex objects. We also have this ability to get the full abstraction, so we can see, okay, this is, we're trying to abstract these items from the background, from the environment, so that we can understand events and behaviors without caring about the background from that. One of the key points here is the number of complex annotations that we can have. So what we see here is we have label bounding boxes, 3D bounding boxes, very, very complex to do or impossible to do with real world data. Semantic segmentation is very expensive to do. Instant semantic segmentation, where you identify individuals and indeed re-identify them later, is almost impossible to do with real world training, with real world data. The depth information we use to create things like point clouds for LiDAR. We have full skeleton data, so identifying the points, and this is something where, again, trying to do skeleton data for pose recognition, pose detection is very, very hard with real world data. And just an example here, sorry, of the output of the, you see we've built up the scenario here, and then the data can be automated to generate the things which tells us who's wearing a face mask and who's not wearing a face mask, and then with the full instance segmentation available as well. We can also go way beyond just that, as I say, the visual world. So we can start to look at LiDAR type data. We can look at distorted data like the fisheye lens and so on. I've already mentioned this, but the ability of the simulator to create whatever instance we want, so we can isolate the image against particular backgrounds. We can randomize that background to abstract from it. We can change the camera position, the lighting, the field of view. All of these will be critical to give your system the robustness it needs. And at the end of the day, once we've created all that data, and we have, we're going to have massive data sets, we're going to have millions of images in our data sets. We have to be able to find that data. We have to be able to create that data again. And so what we've done is we've created a curation manager that can find both real world data that we have stored and our synthetic data. We can analyze that content. We can create the perfect training data set for our needs. This also allows us at this stage to augment our data set. And we use advanced things like style transfer to match the domain. So I can take a city image that I've simulated, which has a European style, and I can transfer that to an Asian style city, an American style city, and we can basically get the same look and feel across a data set. So we can create a data set once, but then we can apply that data set for a worldwide deployment for different locally conditions. The synthetic data allows us to do some significant augmentations that are impossible with real world data. So things like we can change the depth of field afterwards. So we can take something here, like we can have an infinite depth of field. We can have something with a very narrow depth of field. We can relight the images. So we have normal exposure. We can have something here where we've got a color exposure. Perhaps it's the brake lights of a car who's lit up the man's face. Or perhaps the headlights of a car are causing it to be overexposed. So all of these relighting can be done afterwards. So we can take the same base data set and enable that relighting. Jump on. So there's a few examples here, and I'm just going to run through a few of the examples to show the tool in action. So first of all, I'm just going to show one here, which is showing us this is showing how quick and easy it is to configure a particular scenario. Here I'm just doing an example with some items for a shopping example where we're putting together an instance of that. And you can see very quickly, we can generate the people that we want, we place them in the 3D world, and we can set them around, move them about in full 3 dimensions. So we can get everything accurate, everything done, and placing the cameras down, we're getting the previews of what the cameras are going to see. So let me just pause on the camera. Cool. What you can see here is as we simulate something, we can automatically have perfectly synchronized camera views. So here we have a small scene that we put together. All of the camera views are perfectly synchronized. Now for training data, that is something which is very, very useful, but very, very difficult to do with real world data because the camera sync will not be synchronized. But here we can see that the different camera views are all synchronized. And you saw also actually one of the things just to note there, you can see the automated behavior. So we don't need to tell the characters here that you need to step over the pallet. And what you'll see is that they automatically can walk over and step over the pallet. The advanced scripting I mentioned gives us this ability to rapidly create different layouts, different camera views of the data sets that we're creating. The advanced annotations here that you see, so this is showing how we can get facial recognition and facial key point data. You can see that we're automatically labeling all of the key points. And the last one here, this is just showing an example of how in a automated way, people are picking items off a shelf and able to automatically identify the best way to pick the items off the shelf. And even where there is a complex bottle shapes, they can pick them over with the full physics. This behavior is automated. So for the machine learning engineer who wants to create things, they can automatically just tell the person, go and find some milk, find some bananas, and that person will have the automatic behavior, the correct hand grips to pick those items up. You'll see here even understanding that a two-handed grip is necessary. Okay, so just to conclude now, the main issue that you're going to face with any visual AI project is getting the data. Networks and hardware are evolving all the time, but the data is absolutely difficult. You're only going to be able to get the required coverage, privacy, and diversity is by using synthetic data. And you will obviously most likely want to use real world data as well, but you are going to have to use synthetic data in order to complete your project successfully. And then Mindtech's Chameleon is the only platform out there which has that end-to-end ability. So the ability for us to import artwork all the way through to that data curation. And with the AI-driven automations for the simulator, we're the only platform that does that. This is where we've worked with our own internal machine learning engineers. We understand the process that AI developers want, and we've developed the whole platform from the perspective of the ML engineers. So the ML engineers have told us, what they need, how they want it delivered, and we have built this end-to-end platform based with them in mind. So with that, I'd like to thank you for your attention, and I pass back to Sean for any questions.
Hi, Chris. Thank you very much for that. Yeah, so for those of you who would like to ask a question, please feel free to add something to the chat box. I guess one question is that, at the moment, having spoken to a number of companies here, the response is often a little bit around, we can purchase very cheaply, data from China or find it more readily available. I wonder if you can just, in a word, explain, or maybe an example where, that really just isn't enough, because I think that some people still find that the idea that you use something synthetic rather than just keep purchasing real life data is something that is hard for them to get around.
I think there's a number of issues around that, Sean. It's a very good question. First of all, is that data that you're getting, do you have the rights to really use it? So what is the provenance of that data? If you have people in there, have you got the rights to those people? Now, obviously, you may get commitment from your supplier that yes, of course they have, but when it comes down to the future and that deployment in the real world, that's a risk that you're taking as a company. Secondly, the data sets that we have seen, the labeling is often very poor. It's often inadequate, and you see that there are missed features. So there are pedestrians who are perhaps not labeled. You'll see that there are people that are labeled inaccurately. You'll see that there are issues around things labeled incorrectly. So a pedestrian incorrectly identified as a traffic sign. We've seen things as silly as that. So I think the accuracy is another issue. Can you really get hold of that corner case data that you want? So, the example that I had at the end there, where I was actually putting bananas on the floor in front of the fruit and veg stand, that's actually a real world example. That's come from one of our customers who wanted that very specific thing to do because they need to understand it's a very dangerous thing. It is a genuine slip hazard, and they wanted that. Of course, you could ask your labeling company to go and film that and go and accurately generate it, but the time taken and the cost taken would be significant. Even if it's a low cost, they still need the time to go out and create that data. So I think there are significant issues with real world data. Now, I'm not saying we shouldn't use some real world data, but it's certainly only a small part of the solution.
Okay, yeah, understood. And then I wonder, Noman, if I can just bring you in a little bit, maybe as we're coming to a close, if you can talk a little bit about what is the business model? How is it that you work with your clients, and in what manner can they do that? And yeah, I think that would be helpful, not only for the attendees on the call, but also as we send this out to those that weren't able to make it today. So.
Sure. So today our business model is very much one of an enterprise licensing model, where we license the platform either on a term basis, a 1-year term basis, or a 3-year term basis. That gives them access to the full platform, as Chris has described. Typically on first engagement, we also get involved in developing the scene and scenario. That is done in conjunction with the customer. So we develop the scene based on their requirements, whether that be, say, a building site, for example, or an airport scene, or a retail environment. All of those are active engagements that we've got with other customers around the world. So I can't mention any names, but it just gives you a feel for the type of engagements that we are currently engaged with. And then, and during that first engagement, we also explain to the customer how to create their own scenes and scenarios so they become self-sufficient. And then moving forwards, typically the customer will then take full responsibility for their own scene and scenario development. And of course, any of the data that comes out of the platform is theirs to own. So that's the typical business model. We are going to be moving to a server client business model sometime early next year, which this will allow customers to move to a more cloud-based solution as well, where the platform will reside in the cloud and you will have access to the solution on multiple terminals. Therefore, more data scientists can actually access the platform and create their own scenarios and scenes. So, but today it's very much an enterprise license. We do also offer the ability to create data sets for customers. So for those customers who don't actually want to license the platform, but do have an urgent need for data, we will create the data for the customer based on their specification as a service. So that's really the third offering. But ultimately, we find that most customers move to an enterprise license because they want to own the data, which then becomes a valuable asset for the customer as they move forwards.
Okay, understood. So what could you tell us also a little bit just in terms of, you know, sales and projects, at least what you're able to discuss, maybe sectors and countries, types of customers, just to get a flavor of where your solution is being applied.
So even though Mindtech is based in the UK, we have got sales worldwide. So we've got customers in North America and also in Asia. So obviously with the pandemic, it's been very difficult for us to actually travel. So we have local representatives in these areas, similar to Sean, your organization. And we've engaged, let's see, so we've got engagements in Europe in surveillance, standard surveillance, and those surveillance cameras can be deployed in a number of different areas. One that comes to mind is airports, where they're doing detection of people and baggages and so on. So that's one example. Engagements in the US are retail centric. And we also have engagements in the Far East, which are more home centric. So again, all of these are where people are trying to understand and detect human behavior and make decisions based on what they've detected. And in order to deploy a reliable system, they realized that they needed quite a lot of data, much more data than they initially thought. They also found that that data was hard to come by. And of course, all of the issues that Chris has raised with privacy issues and GDPR. So the result of that is they've turned to us, and they've all, in fact, all of those engagements are platform engagements where they've licensed the platform, learned how to create the data, and are now completely self-sufficient and are doing it all themselves.
Okay, great. And then also, obviously, you know, today the call is very much for the audience here in Korea. So I wonder where you see the opportunities and why Korea. I mean, obviously, it has a, you know, it's a leading country in terms of technology, and so the reasons are rather obvious. But maybe some of the areas and applications specific to this country where you think there's opportunity for some sort of collaboration or potential client, and then in the event of that, what you think a good first step would be for anyone that's interested in your solution.
Sure. So with regards to why Korea, both Chris and I, and in fact, you know, pretty well everyone at Mindtech, we've been involved in the high-tech industry for a long period of time, previously selling intellectual property, both of either software IP or hardware IP. And Korea has always been a market that, you know, historically we found to be very receptive to new ideas and new thoughts. They've been quite innovative in their approach. So for us, you know, trying to target Korea is a natural home for us. We've all, you know, pretty well everyone within Mindtech has done business in Korea before. So that's, you know, and you've got, you know, a lot of innovation in Korea as well. AI, I think, is such a big growth industry. And, you know, if I look at the types of customers in Korea, whether you've got big, you know, big conglomerates through to smaller companies that are still market leaders in this space, for example, in the surveillance camera space, you know, you've always shown a lot of innovation. Korean companies have always shown a lot of innovation, and AI is touching all different industries. And we know that as AI proliferates through these industries, the need for training data is going to rise and rise. And we'd like to think that Mindtech can help the Korean companies really develop world-class AI systems using our solution for, you know, state-of-the-art training.
Okay, yeah, that's clear, and let's hope that there are people interested on the call, and then in the event that they are, I think, we'll leave contact details on the follow-up email as well. And actually, we have a question just come in, and this might be a good one for you, Chris. It's a sort of forward-looking one, and it'd be interesting to what you think on this. But someone's asking, what do you think the future is for synthetic data, and then to some extent, how widely you see it being used, and ultimately, could it replace real-world data at some point?
Okay, so I'll take the last element of that first. It's never going to entirely replace real world data. If you remember back to the early slide I showed, we're always going to need real world data for the test, because that's ultimately what you're using the system with. So there's always going to be an element of a test portion of the data, which is real world. Now, in some of the experimentation we've done, we've been working on a parking lot issue where for a customer, helping them understand empty space in a parking lot. And we've seen on that, phenomenal results with synthetic only data. We're getting accuracies up in the high 90% of identifying empty spaces. That could well be enough for, the use case that is there. So in that case, you may not need any real world data at all. So certainly I see certain applications where synthetic data on its own can be used. In terms of where I see this going, we're all about making our data represent the real world as closely as possible. So that's both visually, and so we keep improving the visual quality, but also more importantly statistically. So being able to model, let's say you've got a busy station in Seoul, and you're trying to monitor how many people are the crowds of people going past, and you want to make sure for safety purposes the crowds of people, so understanding that flow of people and then being able to automate that flow of people to accurately model that at certain times. So we're constantly doing things like measuring statistics and being able to measure those statistics and having good ways to bring that into the simulator. So modeling the real world both visually and statistically, and that level of automation is what we're trying to really sort of keep building on to make the data scientists' life easier.
Okay, yeah. Well, thank you very much for that. And timing wise, we've got 2 minutes. So I think that's pretty much perfect timing to wrap up. So I want to thank you, Chris, for the presentation, also Noman for the support on the Q&A, and also my own team for setting this up, and also everyone here for attending. So we will be sharing the contents with everyone. And for those of you that couldn't make it, please do read your email, and if you'd like to reach out to us, then that would be great. So without any further ado, I'd call it an end here, and thank you again, guys. I'll let you get back to your mornings.
Thank you.
Thank you.
Thank you.